Hello, students of algebra. I'm happy to report that today is my last day of training for coding, and I will be back in the building on Monday. I appreciate those of you who have been sending me messages to tell me things that are working or not working or things that you need help on. And I do appreciate the amount of effort you're making to kind of learn this stuff without me there with you. I will be reviewing it next week. And one other reminder, all iPads must be updated by Monday, okay? They have to be updated. It's extremely important that your iPad is updated by Monday. This is probably the third time you've been told. A couple of people were very honest on the Google form, and I said, is your iPad updated? And you're like, no, it's not. So make sure if you did not do it yet that you have updated your iPad. Okay, a couple of the problems that you've seen in the worksheets you've been doing and on Delta Math have involved quadratics that are in this form. A number times x squared equals c. And there's a term missing. The b term is missing. Okay, so I want you to think about, can you think of a value of x that would make each of the following equations true? What would x be if I square it? I would get 4. I think a lot of you are probably thinking, oh, x is 2. I know that. X is 2. But there's another answer to that question. There's another number, and I'll admit, we don't think of it very often, that if we multiply it by itself, we get 4. Can you think of that number? It's -2. So each time that we look at a question like this, there are two answers, the positive and negative square root of 4. So for the next one, if you want to undo this squared term, you would say, well, x is equal to the square root of 1. Don't be so quick to say 1. It's actually both positive and -1. Sometimes you'll see it written this way because I told you mathematicians are into shorthand. So that's the fastest way you can write 1 and -1. Okay? So I'd like you to pause the video and figure out the two values of x that would give you both this equation, this one, and this one. Okay? And you could probably do those very quickly if you know your perfect squares by heart. Okay, welcome back. I hope you have those answers done. I will show you those answers when I make my answer key. A quadratic equation is an equation containing a single variable of degree 2. So single variable means there's only one variable. You don't see anything with x. You haven't seen anything all week with both x's and y's. We're dealing in a single variable, just x. And the degree is 2. Remember, the degree is the value of the largest exponent. And the general form is ax squared plus bx plus c equals 0. You've seen that a few times in these lessons. A is the coefficient on the x squared term. That's your a value. And b is the coefficient on your x term. And c is the coefficient on your x to the 0 power. 0 power is 1. So your constant term that has no x value there at all. Okay? And a, b, and c are constants or numerical coefficients. The only rule for a quadratic is that a is not equal to 0. You could take a second to think about why that's a rule. If a was equal to 0, if you had 0 in front of x squared, that term would be 0, and we wouldn't have a quadratic anymore because our highest degree would not be 2 because this term would be a 0 term, and our highest degree would be 1, which would make our equation a different kind of equation. Can you remember, students of algebra, the name of an equation that has a variable with no exponent, what we call that? Think about what its graph looks like, possibly. Okay, so given this list of equations below, circle the ones that are quadratic. You're simply looking for x squared to be your highest exponent. X squared to be your highest exponent. There's only one, maybe two tricky ones here, okay? When you're looking at it and thinking about it, I would say to pay special attention to this one, because once you distribute, you'll have an x squared, right? And pay attention to this one, because once you cross multiply, you'll have an x squared. And you'll be able to see the answers to that in my answer key, which I will post at the end of the day tomorrow. I'm writing myself a note to post that key so I don't forget. You can remind me if you remember. Some easier quadratics to solve are what we call incomplete quadratics. Now, you've seen some of these as we've gone along, but I want to give you some little hints today about faster ways to do them. Okay? These quadratics are in the form of ax squared minus c. They're missing the bx term because b equals 0. And they look like these, the ones we did in the do now. Okay? For incomplete quadratics, you can simply use the inverse of squaring, which is the, whoops, that's a highlighter. The square root. I'm going to write it all up here. I know the line continued down there, but I want it to be together. Okay? Don't forget to include both the positive and the negative solutions. Negative, I think I spelled that wrong. You need two solutions. Okay? So here we have, it's kind of the same thing we did up above. To solve this, you take the square root of x squared equals the square root of 36. The square root of x squared is x. And the square root of 36 is both positive and negative 6. Now, there are two reasons that you get two solutions. You probably noticed from the Delta Math and from the two assignments on 1201 and 1202, you're getting two solutions, okay? If the degree of the exponent is 2, there will be two solutions, okay? So two solutions if the degree is 2. When we have a linear equation, it only has one solution. If it has one at all. When we have a linear equation, we have one solution. When we have a quadratic equation, we have two solutions. If the highest degree was 4, we would have 4 solutions. Okay, another way to solve an incomplete quadratic is by factoring. This is what you were taught to do in lesson 12.1 and 12.2. You have the quadratic, set it equal to 0. So we're going to minus 36 from both sides. Now factor the quadratic, x minus 6 times x plus 6. That's the difference of two perfect squares. Separate the factors and set each equal to 0. Solve, and you get x equals positive 6 and x equals negative 6. Same solution that I got right here, different way to do the problem. You might say, well, what are the benefits? Do I need to know both ways? Okay, let's talk about it. This way is much faster. Okay, many of you will see this way is much faster. However, many people who use this method forget the negative root. So if you're going to remember that what the square root of 16 has 2 roots, this way is fine. If you don't remember that, then you might want to use this way. Also, when you get a fractional value, it's much easier to do this. The square root of x squared is equal to the square root of 1/4. So x is equal to, when this happens right here, when you have a fraction in a square root, you just put the fraction on the numerator divided by the fraction on the denominator. So you get you get positive and negative 1 over positive and negative 4, which comes out to positive and negative 2, sorry. Oops. I don't want to re-record, so I'm not going to redo that. I erased the wrong 2, kids. Sorry. The square root of 4 is 2. So you get 1/2. Positive and negative 1/2. Okay? Now, this method is great. Some of you will say, oh, I'm doing it this way. If you remember the positive and negative on your answer, you'll be okay. Otherwise, if you factor, it kind of forces you to remember that there's 2 different answers, positive 6 and negative 6. Okay? Now, these 2 are examples of that. You can do that on your own. Now, every time, all the problems we did had numbers that were perfect squares, so it worked out nicely. You can also do it if it doesn't work out nicely, but kind of just stops halfway. Look, I want to get rid of the square in here, so I take the square root of both sides, because what I do to the left, I must do to the right. The square root of x squared is x. What times itself gives me x squared? X. The square root of 10 is irrational. If you put it in your calculator, you're going to get a big long decimal. Just leave it as the square root of 10, plus and minus the square root of 10. That's all you have to do for that. Okay? So you can just put them, if you don't know your perfect squares, there's not that many for you to memorize, but if you do not know them, you can check in the calculator to see if it's a perfect square or not. If you get a big long decimal, you can stop, okay? This lesson, you're going to finish these couple of problems, and then there's a worksheet with very similar problems just for you to practice. You could do that for homework, or you could do that in class today. And then at the end of the period, I'm going to post the answer key to this, okay, this lesson, so you can make sure you have your answers correct. Happy Friday. I'll see you next week.